This problem is asking us to identify a number of terms based on a quadratic. So I know this is a quadratic because I have an exponent right here of 2. That's my highest degree. So this is a quadratic, and it's in standard form. And I know it's in standard form because standard form would be written like y equals ax squared plus bx plus c. So we can clearly see that our a is negative 2/5, our b is negative 12/5, and our c is a positive 7/5. So I intentionally did this problem because it has fractions and it looks scary, but it's really not. So we can identify and pretty much do everything that we need to do by using our calculator. So I go to my y equals and I put my equation in my y equals in the calculator. And if you can't remember how to make it look like a fraction, it's alpha and then this y equals, and then you'll see that it allows you to put in the fraction. So let's just go ahead and look at the graph. So when I graph it, it graphs like this. So I'm going to go ahead and I'm going to sketch the way this function looks. So this is an upside down parabola. And I know that my vertex, which is the first thing it asks me, is located right here. So that point right there is my vertex. So I need to find what the value of that point is at my vertex. So my vertex is at the very, very top of this function. So since my vertex is at the very top, I'm going to write very top. It's at the highest point. That means I'm going to look for a maximum. So in my calculator, if I look for a maximum, I'll be able to find the value of that point. So I'm going to do second trace, and I can see the word maximum is number 4. So you have to be careful because when you do your boundaries, it will pick the highest point, even if that's not the highest point on your graph if you don't select it correctly. So right here it says left bound. I'm interested in this place right somewhere around here. Okay, I'm going to do this. Hopefully it will write on a little bit darker pen. Somewhere around there. This cursor is to the right of that point, so I'm going to move my cursor over to the left side. I'm going to put enter, and you can see it made a boundary on the left of the point that I want. Now it asks for right bound. So I'm going to move my cursor over to the right side. Give it some space. You don't have to be close. You actually don't want to be too close. So you can see now that the point I want is in between my walls. Those are my boundaries. It asks me to guess. I can move the cursor closer, but I'll let the calculator figure it out. So I'm going to go ahead and push enter. And you can see the cursor went exactly where I wanted to go. So it gave me my maximum value. It's an XY coordinate. So I have to be careful. This here is a screen error, so this is actually going to round to -3. So that means that my X value is -3 and my Y value is +5. So that's the value of my vertex. So I'm going to go ahead and that was my vertex. That's what I just did in blue. So now, axis of symmetry. So axis of symmetry. If I were to do a vertical line down the center here, that would be my axis of symmetry. So that axis of symmetry always goes through the X value. So what was my X value? It was -3. So X equals -3. And I'm going to put AOS for axis of symmetry. And notice I wrote it as an equation because this is a vertical line, and vertical lines will always be x equals something. By the way, I needed to point out on here that I actually answered 2 questions when I found the vertex. So I also found the maximum. So I find my maximum by my vertex. So that's my vertex, and it is also a maximum. Okay, but we sometimes want to write these things a little differently. So what I'm going to do, pay close attention. So I'm going to say I have a maximum. Well, it's asking for the output. So what is my maximum output? And what makes it so? Well, I have a maximum output of what? A maximum output of 5 when I put in an input of what? -3. So you'll see it written like that, a maximum of 5 when x equals -3, or you might see it a maximum 5 at x equals -3. Okay, so either one of those is how they would be written because we're interested in our output. So now let's talk about domain and range. So domain are our inputs. So notice I didn't even put in a XY axis here, right? So when I'm talking about domain, I'm looking for those x values. So how wide is the function? It starts way over here and it keeps getting wider all the way here. So my x value way over here, my x value would be at -infinity to infinity. So this is going to be always true with quadratics. So if you want to memorize that, that's always true with quadratics. Okay. The one that's a little tricky has to do with the range. So your range is your y. That's your bottom to top. Okay, so our bottom, this is all the way down, so this keeps going down forever, which means that my y value starts at the floor of -infinity, and as I go up, my highest point, my y stops here. What's my y value? My y value is 5. It includes the 5, it never includes the infinity. So that's domain and range. So we did domain, and we did range. Now this might seem a little scary for you. You might be saying, okay, now I have to write this in vertex form. It's actually fairly easy. It really requires no math at all. We actually have everything we need to answer that question right here. So let's just think about, I should have written this here. This here is, I'm going to write standard form up here. Okay, so that's a quadratic in standard form, and so now I'm going to write a quadratic in vertex form. So here this is again. We've heard about vertex form before. So vertex form, generally speaking, is y is equal to a parentheses x minus h. Because this is a quadratic, we have to put squared plus k. So remember, your HK is your vertex. So we already have that value, don't we? We have it right here. So our HK is -3 and 5. So I can simply substitute those in. Now you may be saying, okay, but what about the A? Well, that's easy because look at, here's the letter A. We have the same exact letter A here, which means our standard form already gave us the value of A. So I know that my A is -2/5 because the A in the vertex form is the same as the A in the standard form. So now all I have to do is substitute in my values. So that means I have y is equal to, well, A is -2/5. x minus, be careful here, we have to put in our h, and our h is -3 squared plus our k, which is 5. So I have to clean this up because I have a negative. So my final equation would be y is equal to -2/5 x plus 3 squared plus 5. So this is my quadratic in Vertex form. So I can check this. So on my calculator, I had my original equation, so that was in y1. So now let me see if I did this correctly. It's always a good idea to check. So now I'm going to do alpha f1, excuse me, wrong button. Let me go back. Alpha f1, I'm going to do my fraction. I'm going to put in -2/5, and then I'm going to put in parentheses x plus 3 squared, and then plus 5. So when I graph this, they should graph exactly the same, which they do. You can see it's tracing right over the function. The other way to check is go to your table. Still graphing. Oh, here we go. And I can see my y values are exactly the same, so I know I put this in Vertex form correctly.